Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about circular permutations examples. In our last class, we clearly discussed the formula, how we solve the circular permutations. Please watch that class and come back here. The link for the playlist is provided in the description below. Coming to today's class, so the first two examples are simple. The third one is little bit complex to understand. Take the word hello, H-E-L-L-O. How many circular permutations possible using these characters? So we already know how many characters are there. 1, 2, 3, 4, 5 characters are there in the word H-E-L-L-O. So 5 characters can be arranged in circular arrangements in, if you are having n characters, n minus 1 factorial is the equation, is the formula for circular arrangements. So 5 characters, so that's why 5 minus 1, which is 4 factorial, is our output. But the point you need to understand here, L is repeated 2 times. Permutations with repetitions concept. Whatever the concept which we discussed in our previous classes, permutations with repetitions, apply that concept here. It is applicable to circular permutations also. Yes, 4 factorial, this is the total possible ways. If you are having repetitions, L is repeated 2 times, that's why 4 factorial by 2 factorial. So our total output is number of ways we are going to arrange the hello characters that present in hello in circular permutations is 4 factorial by 2 factorial. Let's take one more example. If you take the word circular, the same word we are taking, how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8 characters are there. So n is equal to 8. What's the formula for n minus 1 factorial, which is 8 minus 1, which is 7 factorial. But we are having repetition. C is repeated 2 times, R is repeated 2 times. That's why 7 factorial divided by 2 factorial, 2 factorial. This is the output which we are having circular permutations for this word. Similarly, the third example, this is bit complex to understand. Let's take that P, Q, R, S, T, U, V, W. These are the alphabets they have provided, and they are saying that P, Q, R, S, consider them as boys. You name it as P, Q, R, S. 4 boys are there. T, U, V, W, consider it as girls. So, see, if you take P, Q, R, S, T, U, V, W, total how many alphabets are there? Boys and girls are there? 8 boys. 4 boys and 4 girls are there. Total how many are there? 8. How many ways you are going to arrange them in circular order? N is equal to 8. 8 minus 1, which is 7 factorial. This is the total possible circular arrangements, but they are not asking the question that much of simple. They made it little bit complex. So let's try to understand what's the question. Circular arrangements you have to do where no 2 boys sit together and no 2 girls sit together. So no 2 boys sit together and no 2 girls sit together. What's that mean? How the arrangement should be? So now these are the 8 positions. Let's take the 4 boys P, Q, R, S. In between leave 4 positions. If you place girls in these positions, then this is the possible way where you can arrange boys and girls that satisfies the condition that no 2 boys sit together and no 2 girls sit together. So now how to solve this? Let's take this P, Q, R, S. You take only boys. Now we are going to arrange these boys in circular order. Means 4 boys can be arranged in circular order in 4 minus 1 factorial ways. Means 3 factorial ways. So this is one of the pattern. P, Q, R, S is one of the pattern. If you place boys in circular fashion, the gaps that between 1, 2, 3, 4, these 4 gaps can be filled with the 4 girls that are present. T, U, V, W. But the point you need to understand, the girls 4 positions can be filled with 4 girls in 4 factorial ways. Don't consider it as a circular way because we are having 4 positions. You need to fill these 4 positions with 4 girls. For each of this boys pattern, you are going to arrange 4 girls in 4 positions. So that's why you can arrange this boys pattern in 3 factorial ways, because we are taking it in circular way. Girls, we don't need to consider them as a circular way. We have to take them as 4 positions filled with 4 girls. That 4 factorial ways. So 3 factorial multiplied by 4 factorial. These are the number of possibilities you are going to get if you arrange boys, no 2 boys sit together and no 2 girls sit together. So try to understand it properly. This is bit important to understand. Many times they are going to ask this type of questions. So 3 factorial. Why multiplication? These type, for each pattern we can arrange girls in 4 factorial ways. How many patterns are there? How many boys patterns are there? 3 factorial patterns. So that's why 3 factorial multiplied by 4 factorial. Hope you understand these examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.